Fishy, you are absolutely correct. You can only take the determinant of a square matrix. So for this second one, this determinant is going to be undefined here. For the first one, we should be able to calculate that determinant, and I think you're right, it should be 16, right? Is it negative 16? So it should be negative 15 minus 1. Yeah, so negative 16. Nicely done. So we have basically like three... Oh man, I'm going to maybe write this down. Watching physics videos, yes, we could do that too. We could do that. So what I usually do for these 3x3s is I usually use like the fast method. And so the fast method, I'm basically going to take the first two columns and rewrite them down. So I'm going to take this first column, which is negative 3, negative 2, negative 5, and then 1, negative 5, and negative 3. And once I do that, then I need to go through and I need to do these three multiplications, and we're going to add those numbers. So my determinant is going to be, looks like negative 15. That's the multiplication of this first diagonal. And then negative 5. And then plus 6. So I'm going to be adding the numbers that I get on that particular, these three diagonals. And then I need to subtract these three diagonals from what I originally have. So I need to subtract 2, I need to subtract 9, and then I need to subtract 25. And then whatever this sum is should be our determinant, hopefully, if I did that correctly. Let me know if I made a mistake anywhere in there too, but I think everything looks okay. So negative 15 minus 5 plus 6 minus 2 minus 9 minus 25 gives us a negative 50 for our determinant. Negative 50. Oh, nice. You got it, Fishy.
QED.
Yeah, it's pretty easy to do it without rewriting the columns as well, but this is a nice strategy. Like if I just had this like matrix sitting here and I was like doing a test or something, I usually just write the numbers right beside my matrix because usually you have like a little bit of space, and then that way it's just easy. I don't make any mistakes trying to like loop around to the other side. But yeah, so this one should be possible. We should write that one. That's going to be negative 50. Nice. Okay, use the shortcut for finding the inverse of a 2x2 matrix to find the inverse of 4, 0, 2, 1. So we need to get the determinant first, which is 4. So we need 1 over the determinant, right? 1 over the determinant. And then how does this work? We have to swap these and negate these ones. Is that how that works? So it should be 1/4, 0, negative 1/2, and 1. I tried a 4x4 by hand once and was never the same. Yeah, very true. Very true. That will change you. It will change you. You'll become a new person after doing a 4x4 determinant by hand. What do we think about question 3? A square M is invertible if and only if its determinant is not 0. True or false? 4x4 matrices are meant for calculators. True. Where's Danny? When's Danny coming back? Where is True? True. Yeah, this one is definitely true for sure. Question 4. Find the determinant of the matrix. That one's not too bad because it's diagonal. This one should just be negative 4. Right, it's negative 4, take away 0, right? So that one's not too bad. Question 5, find the inverse. Ooh, find the inverse. Well, we need the determinant first, which is negative 8 minus negative 5. So that is negative 3. So I need 1 over the determinant times 4, negative 2, negative 5, and 1. So what do we get here? Negative 4/3. So negative 4/3, 5/3, negative 1/3, no comma, and 2/3. Is that what that looks like? All right, and if we need to enter that as a matrix, just be mindful, like my students, just be mindful that you may have to write that in that kind of block notation, just depending on what the question wants for input here. Okay, find the inverse of the matrix using row operations. No. No. Okay, so the goal is to move the identity matrix from the right-hand side into the left-hand side, and then whatever comes out as a result on the right-hand side should be the inverse. Let's do row 1 plus 3 row 2s to get a 0. So I'm going to 0 this 6 out, and then I'm also going to take row 2 and let's divide by negative 2 or multiply by negative 1/2. So that should give us a 1, a negative 2, a 0, and a negative 1/2. And then I should have 6 plus 6 for 0, negative 2 plus 12, which is 10, 1 plus 0, and then 0 plus 3. So those should be my new row 1 and row 2. And then I suppose what we need to do is to get, let's swap. Let's do a row 2 swapsies with row 1. And then we're going to take row 1 and divide by 10, I guess. So we'll get 1, negative 2, 0, negative 1/2, and then 0, 10, but I'm going to divide by 10, 1/10, and then 3/10. And then the last thing we need is a 0 up top. So let's do row 1 plus 2 row 2s. Fem says, oh no, don't divide. I think we'll be it's a 2 by 2, so I'm less worried about the numbers that are going to pop out here. Because I have the 0 here, right? So this is going to be 0 plus 2/10, so I get a 1/5. That can stay 1/10, that can stay 3/10. It's just going to be this one fraction. It's a bit of a pain in the butt to work with, but that's why we have our calculator. So we're going to take negative 1/2. So negative 1/2, I need to add 2 row 2s, so plus 2 times row 2, which is 3/10, and that's going to give us 1/10. So our inverse should be this 2 by 2 matrix, 1/5, 1/10, 1/10, and 3/10, if we've done our work correctly. I guess we could double check our work, right? We could look at this and go, well, the determinant is 24 minus 4, which is 20. And so the inverse using the shortcut method should be 1 over 20. We're going to swap the 4 and the 6 and then negate the 2 2's. And hopefully everything comes out okay. We need 4 over 20, 2 over 20, 2 over 20, 6 over 20. I think it came out okay. I think that's good. I think those are the same thing. The two fields do intersect, yeah. Sometimes they intersect quite a bit, actually, depending on where you want to go. Does the matrix A have an inverse? No. These two rows differ by, they're a fact. they're similar up to a factor of -1, right? So the idea here is that because I can take row 1 and multiply it by -1 to get to the second row, we basically have two similar rows inside of our matrix, so it's not going to have an inverse. Its determinant should be 0. Question 8, find the inverse of the matrix. Sure. So the determinant here should be -42 minus negative... Oh, what? How dare they? I can see it now too. That first row, which is 7, -2, if I multiply that by 3, I get 21 and -6. So that's why I'm getting a determinant of 0 here, because that second row is actually 3 copies of the first row. Damn, so that does not have a determinant. Yeah, this is lower triangular, so the determinant is just multiplying the main diagonal, so 24 times 3, which I think is 72, what you said, right, Fem? So 72. Yeah, totally.
Problem solved.
Okay, that's what I was thinking, Simplex. RREF is the easiest way. It wouldn't be too terrible to do a lower triangular matrix for finding an inverse. I wasn't ready for it, that's all. Okay, last one, I think, is question 10. So we have this one here. The determinant, ooh, what is the determinant of this one? There's a 1 here, right? So it's not lower triangular anymore. So I'm going to use the old-fashioned method, which is to put those numbers here, here, and here. And then I'm going to do some multiplying. So that's 0, that's 0, that's -12. So my determinant is -12 for the addition.
A determinant of 0 means the matrix is singular. Zeta important in linear algebra.
And that's going to be subtraction of 12. Subtraction of -12, sorry. So I should get an addition of -12 and a subtraction of -12. Oh, I see. I can kind of see it by cofactors now, for those of you that know cofactors, right? If I look at like this, right, and kind of get rid of all of this, I can kind of see the dependence. And I can kind of see that row 2 and row 3 are the same row 2, right? So I'm not surprised to see a determinant of 0. Okay, so we get a determinant of matrix A is 0. That means our matrix is not invertible. It does not have an inverse.